Good afternoon. Welcome to the 46th lecture of fluid mechanics subject. So we are in the unit 3 discussing the pipe flows in series and parallel. So we have completed the problems in pipes in series and we are completing the problems in pipes in parallel. So we are having 2 or 3 problems in pipes in parallel problems. Later we are having a topic called power transmission through pipes and their problems. Okay, so today we will discuss this class in this. Today we will discuss these topics in this class. Okay, next. Okay, so here we have seen the various formulas in the last class also. So today's class also we will discuss the formulas and we will move ahead. Okay, so keep these formulas in mind till your 2-1 subject is completed. So this is a formula for Darcy-Weisbach equation. This is a formula for Sazy formula. These are the notations where you have to keep in the problems. Okay, next. So for the minor losses and major losses. Okay, so these formulas are for minor losses. Okay, these formulas are for minor losses. These are all the formulas coming for minor losses. Okay, so these are all considered as minor losses. Okay, these formulas consider as major losses. This considered as a major losses. Okay, so the last class we have stopped here. So we'll continue this problem and we'll start the next concept, that is power transmission through pipes. So you have to practice the problems or else you will easily forget the concept. Okay, so let's take some time, prepare some problems, practice some problems, right? Next, a pipe diameter of 0.4 meter, length is 2000 meter, is connected to the reservoir at one end. So here you are having 2 reservoirs like this. The other end of the pipe is connected to the junction, which 2 pipes of lengths of 1000 meters and 300 mm run in parallel. These parallel pipes are connected to other reservoir, which is having a level of water 10 meters below the water level of the above reservoir. Determine the total discharge if coefficient of friction F is equals to 0.015, neglecting the minor losses. So what's happening here? So here, so he's saying that the water level ఈ first container లో water level, second container లో water level difference వచ్చేసి 10 meters అన్నారు. That's why the difference is like this. So that's why the base of this one and the base of this one is not in a same layer. ఇది ఒక పొజిషన్ లో ఉంది, ఇది కింద పొజిషన్ లో ఉంది. ఓకేనా? Now here the length of the pipe from here to here is, so from A to B the length of the pipe is 2000, from B to C the length of the pipe is 1000, but with different diameters. A to B degree you are having 0.4 diameter, B to C you are having 0.3 diameter. Okay, now see the figure. Now writing the given data, what's the given data? 0.4 meter, which is the diameter of the pipe. Then what is the length of the pipe? The length of the pipe is 2000 meters. Next, the other end is connected to the pipes of length 1000 meters. Okay, L1 and L2. Okay, the L1 L2 pipes are 1000 meters and diameters are 0.3 meters. Then what is the difference in their heads? 10 meters. Okay, now applying the Bernoullis equation, therefore HF is equals to 4 into LV square by D into 2G plus 4 into L1 into V1 square by D1 into 2G. Okay, so this is for this L and L1. Now substituting those values here, so we are getting the equation like this. So this is 10 and then this is a 10. Okay, this is a 10. So keep it as 1. Now from the continuity equation, AB, AB, AB is equals to BC plus BD, BC plus BD. Now taking the losses. So pi by 4. So the discharge through AB is equals to discharge through BC plus BD. So discharge ఉన్నప్పుడు ఏమొస్తుంది? Area into velocity. Therefore, area is pi by 4 d square into V is equals to pi by 4 d1 square into V1 plus pi by 4 d1 into d square into V2. So this is a equation. Now, therefore, in the second pipe lane, in the second case, d1 is equals to d2. d1 is equals to d2 kabatti. Therefore, the d1 is equal to d2. The lengths are also same. Therefore, the discharge is also same. Therefore, v1 is equal to v2. Therefore, ఈ ఈక్వేషన్ లా రాస్తున్నాము pi by 4 d square v is equals to pi by 4 d1 square into v1 plus pi by 4 d2 into v1. Why? Because v2 is equals to v1. Now after keep on substituting this one, so finally we are getting the value v1 is equals to 0.888 v. Now substituting the value, of v1 in the equation 1. Equation 1 eklundi, this is the equation 1. Deen lopala substituting the value of v1 here. So take those equation, substitute the value at this point. At this point, we are getting 23.325 v square. Therefore, v is equals to this 10 root of 10 by 23.325.64654 meters per second. That is the velocity for the pipe, that is AB. Now, what is the discharge Q? Q is equals to V into area. Then what is the V here? This one. Area is equals to so and so 0.4. Finally, 0.822. Discharge for the flow from A to B is this one. Next, taking the second case. So this is a discharge what we are getting. So determine the total discharge if F is equals to this one, neglecting the minor losses. The total discharge of this connection from here to here is 0.882 meter cube per second. Next problem. Two sharp-ended pipes of diameters 50 mm, 100 mm respectively. Two sharp-ended pipes. Diameter వచ్చేసి 50 mm and 100 mm respectively. Each of the length 100 mm are connected in parallel to two reservoirs, okay, which are having the difference of level 10 meters. Okay, same, the 10 meters. So the height of the reservoir water level, ఈ రెండింటి మధ్య distance వచ్చేసి 10 meters. Then what is saying that the sharp ended pipes of diameter 50 mm and 100 mm. So one pipe వచ్చేసి 50 mm diameter, the other end pipe is 100 mm diameter. Then the length of the both pipes are same. Okay, the length of the both pipes are same. Therefore, if the coefficient of friction for each pipe is 4F is equals to 0.32, calculate the rate of flow, discharge control for each pipe and also the diameter of the single pipe 100 mm long, which would be given the same discharge if it were substituted for the original two pipes. Right? Now, what is the given data? So take the first pipe. The diameter of the first pipe is equals to D1 is equals to 50 mm, 0.05 meters. Then the length of the first pipe is equals to 100 meters. Then the diameter of the second pipe is equals to 0.10 meter. Then the length of the second pipe is equals to 100 meters. Then what is the difference in the levels? The difference in the levels is 1000 meters. The difference in the levels is 10 meters, that is 10. And what is the coefficient of friction? 4F is equals to 3.32. Therefore, F is equals to 0.32 divided by 4. You are getting some value. Okay. Next. Then what is the consideration here? So velocity is not given in the given data. Therefore, V1 is the velocity of flow in the pipe 1. Vt is equals to velocity of flow in the pipe 2. Okay. When the pipes are connected in parallel, the loss of head will be the same. Okay. When the pipes are connected in parallel, the loss of head will be the same for the parallel for the both of the pipes. Therefore, we are taking the first pipe into consideration. Okay. For the first pipe, the loss of head is given as H is equal to 4F1 into 4F into L1 into V1 square by D1 into 2G. That is equal to, so what is 4F? That is 0.32 into 100. What is the length? 100 into V1 square by 0.05 into 2 into 9.81. Therefore, 10 is equals to so and so V1 square. Therefore, V1 is equals to 0.5535. That is a value. Next, what is the rate of flow discharge in the question? The rate of flow of discharge of the first pipe is Q is equals to velocity into area. Then what is the velocity? Velocity V1 already we have measured here. Already we have solved. Okay, 0.5536 into area. Area into pi by 4 d1 square. So we know the value of d1. Therefore, the q1 is equals to so on. So q1 is equals to 1.087. So from the second pipe values, second pipe the loss of head efficiency 10 is equals to 4f into L2 V2 square by D2 into 2G. That is equal to 0.32 into 10, 100 into V2 divided by 0.10 into 2 into 9.81. Therefore, what is V2? V2 is equals to root of 10 into 0.10 into 2 9.81. Can the pi calculate the pi can the 0.32 into 100, that is equal to 0.783. Then the rate of flow, just pi madriga, the rate of flow in the second pipe Q2 is equals to A2 into V2. Therefore, what is A2? Pi by 4 D2 square into V2 value. So pi by 4 D2 value is 0.1 square into V2 value already we have got it, that is equal to 0.783, that is equal to 6 liters per second, right? 6.15 liters per second. That is a discharge. Then what is the thing you want to find? So D1, D2, L1, L2 వచ్చింది. Now the diameter of the single pipe which is substituted for the two original pipes. So ఇక్కడ కండిషన్ ఏమి ఇచ్చాడు? So instead of having two pipes మనం parallel గా పెట్టి యూస్ చేసే బదులు ఈ 2 ప్లేస్ చేసేసి ఒకటే సింగిల్ పైప్ పెడితే then what are those measurements అన్నాడు. Therefore the diameter of the single pipe which is substituted for the two original pipes, L is equal to length of the single pipe 100 meters, but the velocity through pipe V, capital V, and the diameter V changes. Therefore, the discharge through that V, discharge through the single pipe, Q is equals to Q1 plus Q2, that is equal to 1.8 plus 6.15, that is equal to 7 liters per second. Now basically velocity is equals to Q by area. Then what is the Q here? Capital Q is equals to this value. So once we get the value kavatti, based upon this Q information, we have took the formula V is equals to Q by area. Okay. Now therefore, Q value substitute there, area pi by 40 square. Then simplifying this one. Okay, simplifying this one, 4 into 0.07 by that is equals to so on. So finally 0.009 divided by d square meters per second. Got it? Next, what is the thing? Next thing, loss of head through the single pipe. Loss of head through the single pipe, capital H is equals to 4 into F into L into V square by D into 2G. D into 2G. Therefore, 0.32 into 100 into so on so divided by D into 2 into 9.81. Therefore, 10 is equals to 0.32 into 100 into 0.009 divided by 2 into 9.81 into d to the power of 5. Therefore, getting the values, therefore d5 keeping the left hand side. So we are getting the value d5 is equals to 0.4401384. Therefore, capital D is equals to 0.1067. That is 106.7 mm. Right? So like this you have to derive whenever you are converting the two parallel pipes into single parallel pipe by taking the values. Got it? So here condition em ichadante, calculate the rate of flow for each pipe and also the diameter of the single pipe 100 mm long, which would be the same discharge if there is a substitution for the original pipes. అంటే ఈ 2 pipes బదులు సబ్స్టిట్యూషన్ సింగిల్ ఒరిజినల్ పైప్ పెడితే దాని ఫ్రిక్షన్ సేమ్ అయినప్పుడు ఓకే విత్ 100 meters length then what happens to the rate of flow? The rate of flow will be changed. The rate of flow ఎంత వచ్చింది? The rate of flow is 6.52 liter, that is 1.087, but here the rate of flow is Q is equals to so and so. Okay, so and so. The D is equal to 1.6. So the 1.6 అనేది తీసుకుంటే then the velocity of the then the velocity will be totally the discharge will be changed. Next. Last problem in this parallel problems. So hope you are understanding this series and parallel problems. You may not know in the third unit which question you will get. Minor losses రావచ్చు, major losses రావచ్చు, parallel flows రావచ్చు, series flow రావచ్చు. We cannot expect. But only the thing is ప్రతి మోడల్ కి నేను 2 questions, more than 2 questions నేను మీకు explain చేస్తున్నాను. Right? 2 reservoirs are connected by the pipe. Line of diameter 600 mm. Line of diameter 600 mm. And the length is 4000 meters. So total length is 4000 meters. In that the line of diameter is 600 mm. Diameter is 600 mm. The difference of the water level in the reservoir is 2 meters. So రెండిటికి difference if here వేయాలి, figure also carries 2 marks. So it is making a distance of 20 meters. So this is the difference. At the distance of 1000 meters, from the upper reservoir, a small pipe is connected to the pipeline. And at the end of 1000 meters, total 4 launch at the end of 1000 meters, a small pipeline is attached downward to the pipeline. Then the water can be drawn from the small pipe. So the water separately can be drawn from the small pipe. Find the discharge of the lower reservoir. So manaki connection, this process is same. So but it is open to it, and this from here the water is discharging to a lower reservoir. If the lower reservoir low తగ్గిపోతూ వస్తుంది. Therefore, what is the condition there? No water is taken from the small pipe. So from the small pipe, there is no possibility of taking the water. No water is taken from small pipe. Second one, 100 liters of water, 100 liters per second of water is taken from the small pipe. Next, taking F as a distance, neglecting the factor, F is equals to 0.005. So these are the conditions. So then what is the given data here? The given data of the diameter of the pipe is small d is equal to 600 meters, and the length is equals to, the length of the pipe is 4,000 meters. Okay, 4,000 meters. What is the difference in the head level? 20 ml. Then what is the F here? 0.005. What is the first condition? No water is taken from the small pipe. So from the small pipe, no water is to be lifted up. Then what happens there? The head loss in the AB, the head loss in the A versus B. Okay, next. The difference in the water level is H is equal to 20. So see here the H is equals to 20 and F is given in the question as 0.005. Now take the first thing, no water is taken from the same small pipeline. Therefore, the loss of it at AB is equals to HF, that is AB is equals to 4 into L into F into V square by D into 2G, or AB value already we know that 20, 4 into F we know that 4000, L we know that V square into V square divided by 0.6 into 2 into 9.81. Therefore, after substituting V taking this side root of so and so, we are getting V is equal to 1.715. So after getting V, simply get the area. The area is equals to area in discharge is equals to area by volume. area by volume. Therefore, pi by 4 d square 0.6 higher into 1.7. There's easy. To 0.485 meter cube per second. That is the first case. Then what is the second case? 100 liters of water is taken from a small pipe. So ఇక్కడ ఉన్న కనిపిస్తున్న మీకు pipe, this pipe. So initially no water is taken. Now 100 liters of water తీసుకుంటే what is the discharge? Now at that point Q1 is equal to discharge through pipe AC. What is the discharge through pipe AC? This pipe. Discharge through pipe AC and discharge through pipe CD. So discharge to the pipe AC and therefore, so H is equal to 10 is equals to 32 into 9.81 into 9, 214 is divided by 2.991 into 9.81 to the power of d to the power of 5. Therefore, keep on substituting this value, you are getting this one. So from here, d to the power of 5 is equal to so and so. Therefore, d is equals to what to the power of 5? That is equal to 106.7 mm. So this is a diameter of this pipe. Next. So after taking the discharge Q1 value, discharge to pipe AC, discharge to this pipe A to C. Okay. Next, discharge through pipe CB, discharge to pipe correct, discharge to pipe CB and Q1. Therefore, the total of the parallel pipes cavity. Then for the parallel pipes, Q is equals to Q1 plus Q2. Okay. Or Q1 is equals to Q2 plus 100 liters per second. 100 liters of water is taken from small pipe another. That's why Q1 is equals to Q2 plus 100 liters. That is equal to Q2 plus 0.1 meters cube per second. Okay. Okay. Next, Q2 is equals to Q1 minus 1. That is equal to L1 is equals to 1000 meters. L2 is equals to 3000 meters. Right. Therefore, L2 value is equals to, so Q2 is equal to Q1 minus 0.1. Therefore, the length of the pipe AC is equal to 1000. Length of the pipe CB is equals to length of the pipe CBPC here. Length of the pipe AC, length of the pipe BC. Therefore, 4000 minus 1000. 4000 minus 1000, that is equal to L2 is equal to 3000 meters. Now, applying the Bernoullis equation, HF is equals to 2 pipes grind. That is 4 into F into L1 V1 square by D1 into 2G plus 4 into L2 F into L2 V2 square by D2 into 2G. Therefore, we got the value of V, where V1 is equals to velocity through AC. Velocity through AC. Therefore, Q1 by pi by 4 d square into 40 into 36. Right? So after getting this one 20 is on so value. So V1 value velocity of pipe through AC. Therefore, Q1 by pi by 4.6 square, that is equal to 4Q square, 4Q1 into pi into 3.6. Therefore, the diameter of the pipe AC is equals to 0.06. Therefore, now taking the velocity through the pipe CB, velocity through the pipe CB. Therefore, Q2 by area. So after substituting this one, D2 is equals to of pipe is 0.6. Substituting these values in the above thing, so we are getting 20 into 4 into 0.005 into 1000 by 0.06 into 9.81. So into this one. So finally, we are after solving this problem. So after solving this problem, 20 is equals to 1 is equals to 1 square plus 63.75 Q2 to the power of 2. But in the first equation, this equation, what you have done, Q2 minus Q2 is equals to Q1 minus 0.1 or Q1 is equals to Q2 plus 0.1. Substituting Q1 value in the above 3 equation. So we are getting 20 is equals to 21.25 into Q1 plus 5 substitute Q2 plus 0.1 plus Q63 into 0.75. Therefore, keep on doing this one separate, keeping aside this one. So we are getting 85 Q square plus 4.25 Q plus 2.2125. Right? So after doing this one, so So finally, after doing this value, getting this one. So after relaxing, Qt is equals to minus 4.25 plus or minus root of so and so into 2.2 into -5. So after keep on solving this one, keep on solving. So we are getting Q is equals to 0.458 meter cube per second, right? So here the negative vachna koda, you should neglect the negative. Therefore, the discharge to the lower reservoir is equals to 0.458. Okay, so these are the real time values you can do in this concept. Okay. Our last 10 minutes to join out another. Hope you understood these parallel problems. Now, the next concept is power transmission through the pipes. Power transmission through pipes. So the power, how the power is transmitting through the pipes which are under laminar flow or in the turbulent flow. Okay. The power is transmitted through the pipes. Okay, the power is transmitted through the pipes by flowing the water on other liquid or other liquids flowing through them. So the power is generated, is transmitted through the pipes when a high jet of water is flowing through the pipe, right, etc. The power transmission is depends upon two criteria. One is the weight of the liquid flowing through the pipe. So in the pipe, whatever the fluid is flowing depends upon the length of the pipe and the diameter of the pipe. What is the weight of the liquid? And what is the second one? The total head available at the end of the pipe. So what is the second option? The total head available at the end of the pipe. So what's happening at the total end at the end of any given pipe? So what are the main things here? So the first thing is the weight of the liquid to be considered. Second thing is the total head available at the end of the pipe. Now consider AB, connecting AB pipe length, AB pipe, making that a length, right? Consider the pipe AB connected to your tank as shown in the figure. So draw a tank, draw a pipe. So whenever you're drawing the pipe, don't draw like this. It gives a negative impression. So write the pipe in this way. So if you are not maintaining downside, so it's not valid figure, right? So consider the pipe AB connected to the tank as shown in the figure. The power available at the end of the B of the pipe and the condition for maximum transmission of power will be obtained and mentioned below. So very simple, draw a container, draw a pipe, mention the names, the height of the pipe, the diameter of the pipe, A, B, that's it. Right? Now by seeing the figure, let L is equals to length of the pipe. Small d is equal to diameter of the pipe. H is equal to total head as the total head of the pipe. Now the diameter of the pipe, H is equal to total head loss available in the inlet of the pipe. Therefore, capital V is equals to velocity of flow pipe. HF is equals to loss of head due to friction and F is equal to constant of friction. So the head available at the outer pipe, if minor losses are neglected, we can write total head at inlet is equals to 4 losses of head due to the friction. Therefore, so total head at inlet is minus loss of head due to friction. Therefore, total head and H, right? H minus loss of head. H minus HF, that is equal to. So the head available out of the pipe, the minor loss are neglected. The total head at the inlet is equals to loss of head due to the friction. Okay. So by taking this equation, H minus HF is equals to H minus HF formula already you know, the friction formula. H minus HF is equals to capital H minus this value. Therefore, weight of water flowing through pipe per second, weight you can call. Therefore, weight is equals to rho into G into volume of water per second. That is equals to rho into G, volume, area into velocity, volume into area into velocity. Therefore, rho into G, pi by 4 d square into velocity. Therefore, the power transmitted at the for the outlet of the pipe is equals to weight of water per second into head at outlet. So, what is the weight of water? Rho into G, pi by 4 d square into V. Then what is the head at outlet? The head at outlet is this one, right? H minus H into F into L square into V square by D into 2G. Now you are getting the resolve. Right? So after doing this one, write the weight of the pipe into head of the head at outlet. Now power transmitted throughout power transmitted at outlet of the pipe, capital P is equals to rho into G. Rho into 1000 divided G into 2.81. So rho into G divided by 1000 pi by 4 d square into capital V. Therefore, P is equals to rho into G by 1000 b pi by 4 d square into capital V. H of 4 into F L V square by D into 2G. So take it as one equation. Now, the efficiency of the power transmission, efficiency is equals to power available at the outlet of the pipe. So power available at the outlet and the power available at the outlet of the pipe divided by power supplied at the inlet of the pipe. So how much power is supplied? This one, outlet by inlet of the pipe. Now power is equals to weight of water per second into head available divided by weight of water per second into head at inlet, head at outlet. Now W into H minus HE or HF, capital H minus HF divided by W into H. That is equals to H minus HF by HF. H minus HF by H. Right? So this is a power transmission problem. Right. So therefore, W weight of the water per second, W into head available at outlet, H minus F divided by weight of water per second, W into head at inlet, H. Therefore, HH cancel, HH cancel out కాబట్టి H minus H by F. H minus H by F. This is the power of the flow of the pipe. Then what is the condition? What is the condition for maximum transmission of power? The condition for the maximum transmission of power is obtained by the differential equation 11.21. So with this we can do the differential equation. Therefore, with respect to the V, so we are getting what? dP by dV to the power of P is equal to 0. Why? Because the d by dV, P and the value, P is equals to rho into G by 1000 into pi by 4 d square into HV minus 4, so on so, right? This one is equal to 0. Now keep on substituting. So what are the common things? So now take rho G by 1000 into pi by 4 d square into H of minus 4 into F is equal to 3 into H is equal to, right? So 4 into 3 into F into L into V square divided by 2 D into 2G, that is equal to 0. Therefore, H minus 3 into 4L 4FL V square by D into 2G, that is equal to 0. H is equals to minus 3 into HF. So you formula HF together, that's why it took as HF minus 3 into HF is equal to 0. Therefore, H is equals to 3HF. That is equals to HF is equals to 3 by 3. HF is equals to 3 by capital H by 3. HF is equals to capital H by 3. Then what is it? This is the condition for maximum transmission of power, but here maximum efficiency of transfer of power. Now the efficiency of power transmission through the pipe is given by efficiency is equals to capital H minus H by HF. Okay, this is the main general efficiency. Capital H is equal efficiency is equals to capital H minus HF by capital H. For the maximum transmission through the pipe of the condition is given by the equation. We know that HF is equal to H by 3. Substituting the value of HF in the equation, we get, you can substitute just there. Efficiency is equals to capital H minus H by 3 by 3. That is equals to 66.7%. Right or no? So HH is this is there. 1 minus 1 by 3 is equal to 3 into 1, 1, 3 plus 1, 4. Sorry, 3 into 1, 1. 3 1 so 3 minus 1, 2, 2 by 3 or 66.7. So like this also we can do the problems whenever we are getting power as a concept. Okay. Now we'll do the one problem and we will. So we're having okay. So hope you understood how the power transmitted through the pipe. So the power is transmitted in this way. Okay. Either laminar or turbulent flow. Now, a pipe of diameter 300 mm, length is 3500 meters, is used for transmission of power. Okay, a pipe of diameter 300 mm, length is 3500 is used for transmission of power by water. Power transmission is done by water. The total head at the inlet of the pipe is 500 meters. Find the maximum power available at the outlet of the pipe with the value of F is equals to 0.006. Now, what is the given diameter there? Okay, so given diameter of the pipe is 300 meters. That is D is equals to 0.3 meter. Next, what is the length of the pipe is given? The length of the pipe is 3500. What is the total head at the inlet? F is equal to 500 meters. F is equal to 0.6. Now, so we are having the pipe diameter and each short of the maximum power available at the outlet of the pipe. So HF is equals to capital H by 3. So what is the capital H here? Total head at inlet 500 by 3, that is equal to 166.7. That is equal to HF. Then what is the normal head loss? HF is equal to 4 into F into L into V square by D into G. Therefore, what is you know? F you know. L is equal to 3500 into V square divided by so and so. The value is 14.27 V square. HF is equals to 14.27 capital V square. Therefore, equating the values of HF idi. So therefore, 16.67, right? 16.67 is equal to 14.27 V square. Therefore, capital V is equals to root of 166 by 14. That is equals to 3.417. That is equals to velocity. So once you got the velocity, what you have to do? You have to go for the discharge. Discharge is equals to Q into velocity into area. Therefore, what is the velocity here? 3.4 into pi by 4 d square. Then what is the d square? 0.3. So the value of this one is 0.2415. Hope you understood, right? Now, the head available at the end of the pipe. Head available at the end of the pipe is H minus HF. That is equals to H minus, what is HF? H by 3. Therefore, 2H by 3, that is equal to 2 into 500 divided by 3. That is equal to 333.33. That is a head available. Then what is maximum power? So as per the formula, maximum power, this one. So we are using here rho into G into Q into head at the end of the pipe divided by 1000. Therefore, 1000 into 9.81 into 1.25 into capital G. Right? So rho into 1000, rho is 1000, G is 9.81, Q is equals to 24.15, 24.2415. then head at the end of the pipe is that 333, this one 333 divided by 1000, that is equal to 689.7 kilowatts. That is the maximum power available for the pipe. So the time is less. We'll discuss the one more problem and we'll go to the other topic. So I think, hope you understood this topic still here, the power transmission concept. Okay. So after having a free time, just to see what's happened in this slide, in this lecture, right? So hope you understood the problems related to the series and parallel, right? So we are dealing with the power problems. Later we'll deal with the Modi's chart, Hagen-Williams chart, and other equation, right? Hagen-Williams equation. So we'll discuss those things in the next class. So have a nice day. Once this video is uploaded on the YouTube channel, later the link is forwarded to your WhatsApp group. So later you can open the link and watch the videos clearly. So have a nice day. Have a good day.